Good day. Let's continue our review by going back to the power rule of differentiation, which states that if n is a positive integer, then the derivative of x raised to n is n times x raised to n minus 1. And we'll do this by going back sa definition. So by definition, the derivative of x raised to n is equal to the limit as delta x approaches 0 of the difference quotient na f of x plus delta x minus f of x over delta x. But our f of x is x raised to n. So yung difference quotient natin, yung numerator niya, it will be x plus delta x raised to n minus x raised to n all over delta x. Now we'll use binomial expansion to expand yung first part nung numerator natin. And that expands to this. If you recall, yung coefficients ng terms ng binomial expansion natin, sila yung entries ng nth row ng Pascal's triangle. And we could represent each entry in the row as a combination from n choosing 0, n choosing 1, hanggang n choosing n. Taking a look at our numerator, we can see that the first term and the last term, these two ones, they will cancel each other out. So let's start with that. Dun sa matitira, we could make the observation that all the terms sa numerator, lahat sila may factor na delta x. At ano yung nasa denominator natin? Delta x din. So what we'll do is we'll divide each term in the numerator by delta x. And it will simplify like so. Nawala na yung denominator, tapos bawat term nabawasan ng isang delta x na factor. But what are we doing? We are taking the limit of the expression in the brackets as delta x approaches 0. At sa lahat ng terms dun sa loob ng bracket, yung first term na lang yung walang delta x. So when we take the limit as delta x approaches 0, all those terms will approach 0 as delta x approaches 0. Oops. Ayan. So let's evaluate that limit. Mag-0 sila lahat. Matitira lang sa atin yung first term na n choosing 1 times x raised to n minus 1. But what is n choosing 1? That expression simply simplifies to n. And that gives us our power rule for differentiation. Salamat sa pakikinig.